Okay, 6th grade, our objective today is to start chapter 10. So we're going to talk about measurement, area, and volume, which I know you remember a lot of that. So that's why your warm-up was the beginning of the notes. I want to see what you remember. If this is stuff that you're like, oh yeah, this is easy, then I'm going to kind of go a little bit faster through it. If not, we'll go through and have a deeper conversation on what all this stuff is. So 10.1 is just about triangles, okay? I'm going from chapter 7 to chapter 10 because when you do get to the PSSA review, you need to be familiar with geometry concepts. So I'd rather not save this till the end of the year because I want you to be familiar with this, okay? So just triangles for now. The second lesson talks about polygons, okay? So the warm-up, number 1 says, find the sum of the interior angles for each of the given polygons. Yes, there's a way to do this, but I want to hear your strategies. So, of course, the triangle's easy. Matt, how many degrees of interior angles are in a triangle? Good, 180 degrees. Okay, does anyone know how many are in a pentagon? MIH. 500 what? You're close. Charles? Nope, that's for quadrilateral. Doug? Good, how did you know that? Guess. Anyone know how, or know why, I should say? Annalise, do you know why? No, that would have to be a regular polygon, which I'm going to talk about today. Charles? No. 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 I see where you're going, but that's only if it's regular. Matt? Okay. Okay, you're close. Justin? Yeah, but there's a reason for that. You're close. Okay, let's try nonagon. First of all, how many sides is a nonagon? Alyssa? Good. Nonagon has 9 sides. Anyone know? And then maybe you can figure out the formula. Bri, are you with us? Did you do this? Okay. Mary? You said 810? Nope. Matt? No, you're close. Justin? No. Doug? No. Charles? Nope. Annalise? No. 1,260. So here's the formula. To find sum of interior angles of a polygon. First of all, that means the sum of all the inside angles. Here's the formula. The number of sides, which is n, minus 2 times 180. I'll say that again. I'll see you later for that. The number of sides minus 2 times 180. This formula works all the time. This is not in your pre-algebra book. This formula is from geometry. So I'm getting you guys kind of like a little head start with this. So look, a triangle has 3 sides. 3 minus 2 is 1. 1 times 180 is 180. Pentagon has 5 sides. 5 minus 2 is 3. 3 times 180 is 540, etc. It works every single time. 4 if you're finding the sum of interior angles of a polygon. Donatus, you have 1 more minute to finish that. Okay, so n minus 2 times 180. Annalise? You will do the proof on this in 2 years. Okay? It works all the time. Briar? No, I will get to that. Good question, but I'll get to that. Charles? Oh, gosh. Okay, that's a lot. Doug, there's a question? Shh. Okay, nice. Okay, make sure you guys all have the formula written down. N minus 2 times 180. This is for the sum of interior angles of a polygon. I'm going to talk more about what a polygon is and what it is not. Okay? Just wanted to see if you guys knew any of that. All right, so here's the other part of the warm-up. Classifying the triangle. Emma H, letter A. Good. Alyssa, letter B. Perfect. Jeremy, letter C. Good. Emma M, letter D. Perfect. Briar, letter E. Awesome. Letter F, Justin. Awesome. Man, you guys are good. So before I move to the next page, questions on any of these? Okay. Do you understand what it is? All sides are different. Okay. You forgot the word. Mary, question? Yeah. Okay, well, what do you need me to explain? Which one's new to you? Okay. Isosceles is a triangle where two of the sides are the same. So this is isosceles. It has two sides that are the same. Okay? What about scalene? Do you know what that is? All the sides in a triangle are different. Okay? A right triangle has a right angle. Okay? Equilateral triangle, all the sides are the same length. Did you ever hear of that one? Parochial schools are different than public schools with this. Equilateral, all the sides are the same. Okay, acute has does not have an angle measure that's more than 90. So in other words, all the angles are less than 90 degrees. Obtuse has one angle that's more than 90 degrees. That was really fast though, are you sure? Have you ever heard of them? Okay. All right. We're going to get to more of it today. Okay. Annalise? Nope. Just one. Yeah, you won't be able to connect it, so it won't be a polygon. Right, but by definition, it won't be a polygon, which that's very important that we talk about that today. No, we're talking about triangles. So. All right, so example 1A. Anyone want to tell me what X is? Justin? Good. Raise your hand if you got X equals 8. Okay, this one is X equals 8. Annalise, can you tell us how to do this one? Yep. Good. Awesome. Okay, so when you combine like terms, you get 15x plus 60 equals 180. Subtract 60 from both sides, so you get 15x equals 120. And then divide both sides by 15, you get x equals 8. What kind of triangle is this? Alyssa? Yeah, you could say that, but what about by the sides? Good, it's isosceles, and you could also classify this as acute. So I'm going to put isosceles, but it's also acute because all the angles are less than 90 degrees. Annalise? Yep, but we're talking about both. Yeah, it says just to do that, but we can still talk about the definitions just to make sure you guys are very familiar with them. You can put it on my computer. Alini, are you done? Thank you. Okay, so isosceles and acute. Any questions on how to get this? Okay, letter B. What would X be on this one? Mary, do you have X? Okay, go ahead. Perfect. It's obtuse and it's scalene. It's obtuse because one of the angles is more than 90 degrees, and it's scalene because all the sides are different. Okay, who has what X is? Sean? Perfect. X equals 23. Okay, anyone need me to solve? Alyssa? Solve. So for X is 23, you want to add up all the degrees, okay? Each part of that triangle, don't forget, you can add them all up. They're equal to 180. So we have 5x plus 2, that's a 5, plus 2x plus 7 plus 12 equals 180. After you combine like terms, we get 7x plus 19 equals 180. And then Alyssa will subtract 19 from both sides. Are you with me? Okay, so 7x equals 161. Divide both sides by 7, and you get 23. And then what you should do is plug that back in to find what the other angle measures are, and you will find that they are obtuse. You okay? Okay. Annalise? So this is 115 degrees, this one's 53 degrees, and that one, of course, is 12 degrees. So yeah, you need to plug them in to determine. I just didn't do all that since you guys already did. Questions on that one? Okay, Briar, what'd you get for letter C? Okay. Jeremy, did you get to letter C? I know you were taking your test. Okay. Emma M, did you get to letter C?
Yeah, but I didn't.
Okay, do you understand now?
Yeah.
Okay. Charles, what'd you get for C? Good. X equals 15. Mary, what kind of triangle is it? Nope. So X is 15, so when you plug these in, you get this is 60 degrees, and this is 53 degrees. So 67 degrees, 60 degrees, 53 degrees. Mary? Good, it's a cube. Remember, isosceles has to have two of the angles the same and two of the sides the same. Okay? Doug, do you have a question? Okay. Matt? Yeah, it would also be classified as scalene because since all the angles are different, that means all the sides are different. Chloe, you okay? Annalise? What does equilateral mean? Who can tell us? Justin? Good. Equilateral means all the sides are the same length. You cannot go by what the drawing looks like. For it to be equilateral, all the angles have to be the same. If all the angles are different, it's scalene. If all the angles are the same, it's equilateral. Yep. Briar? Correct. For it to be equilateral, each angle has to be 60 degrees. So 60, 60, 60. That would be equiangular and equilateral. So if all the angles are the same, you know all the sides are the same. If all the angles are different, you know it's scalene. What if two angles are the same? What kind of triangle is it if two angles are the same? Emma H? Good, it's isosceles. Okay, you've learned this in the past. It's probably just been a while. All right, any questions on page 2? Okay, let's go to letter D on the next page. Did anyone know how to set this up? Emma H, do you know? That's okay. Go ahead. Perfect. So here's why. So the ratio of the angle measures of a triangle is 1 to 3 to 5. So what that means is extended ratio is 1x plus 3x plus 5x. You know it's the angle measures of the triangle. Okay, so if the ratio is 1 to 3 to 5, it's comparing the angles. So you must put an x next to each of those. And we're going to add all of them up, just like Emma H said. When you add all these up, we get 9x equals 180. What's x going to be, Jeremy? Good, x is 20. But we're not done. Once you find x, we need to put x back into the extended ratio of the angles. So what would these three angles be once you put 20 into them? Annalise, what would these be? I'm getting there. Okay, so I'm getting there. Here's what we're finding, okay? So if the ratio of the angle measures are 1 to 3 to 5, we just found each of the angle measures. So this is not drawn to scale, but I'm trying my best here. So that means one of these is 100 degrees, one of the angles is 60 degrees, and one of the angles is 20 degrees. When you're given an extended ratio of sides or angles, you're finding the measurements. 100 plus 60 plus 20 is 180. So all you're doing is setting up an equation so you can find the degree, okay, or I should say the angle of each part of the triangle. Annalise? You don't have to. You can do what Emma did. Emma just added 1, 3, and 5 and got 9. Okay, because they're telling you that one of the angles is represented by 1, okay, a ratio of 1. Another angle is represented by a ratio of 3, and another angle is represented by a ratio of 5. So if we were to set up a ratio of 1 over 3 over 5 and set it equal to 180, this all works out the same way. But when you have a ratio for a triangle and they're comparing angles or sides, the easiest thing to do is to set up an equation. Because you know if this is the ratio 1 to 3 to 5, 1 times something plus 3 times something plus 5 times whatever that something is has to equal 180. It's just like a word problem, Annalise, but they don't give you all the words. No, it's comparing them. So it means one of the angles is 3 times the other angle. This angle is 5 times this angle. So it's just comparing them. Yeah, it's just comparing them. It's like saying if I had a rectangle, one of the sides is 2 times the other. So that one side would be 2x, but the other side would be x. So again, you're just comparing them. Does that make sense, Annalise? Okay. Charles. Yes, go ahead. Okay, let me just take a time out on that. Is everyone clear on what we're finding? Alyssa? Correct. And if you were to compare these to, or the 20 and the 60, 60 is 3 times 20. And if you were to compare the 20 and the 100, 20 times 5 is 100. So if you check your ratio, it works. One of the angles is 3 times the other. One of them is 5 times the other. All right, just making sure. Okay, let's go to letter E. Okay, letter E. The ratio of the angle measures of a triangle is 3 to 5 to 12. So again, it's comparing the angles in a triangle. One of the angles is 5 times the other. One of them is 12 times the other. So Briar, how would we set this one up? Okay, so you just don't put the x's in. So 3x plus 5x plus 12x equals 180. What Briar said is like what Emma H said. You're adding them all up and then dividing by whatever number is in front of x. So Doug, after you add all these up, what do you get? Okay, 20x equals 180. So Donatus, what would x be? Good, x is 9. Okay, so that's just what x is. We're not done. You need to take the extended ratio. Remember, you're just comparing the angles in the triangle. What would each of these become? The 3x, the 5x, and the 12x, Justin. Yep. Yep. Perfect. Annalise. Well, no. The 5x is not 5 times the 3x. It's 2 times. Well, not even. If you had, let me say it this way. If you had an x here, Annalise, just an x, okay, then this one would be 5 times the x. But you don't have an x here. So think about back when we did scale factors. We're just comparing them. 3 over 5, 3/5, okay, and then 5 over 12. So you're just comparing them. You can set up a ratio. Annalise, if you simplify 27 over 45, what do you get? You can use your calculator. Do 27 divided by 45, math, frac. Yeah, do you see that? So do you see that 3/5? Look, 3 to 5. So going from here to here, you'd have to multiply it by 0.6. Okay, it's just comparing them, that's all. So what kind of triangle would this be based on the angles? Matt? Okay, good. It'd be obtuse based on the angles. Justin, what would it be based on the sides? Scalene. All the angles are different, so all the sides would be different. Okay, let me go back to the other one real quick. What kind of triangle would this one be based on the angles? Matt? Good. Obtuse. Emma M, what kind of triangle would this be based on the sides? Good. Scalene. You guys getting there? Alyssa? Only if it says to. All right. Let's go to number 2A. Raise your hand if you think you got X for this one. Just curious here. Okay, Briar, what'd you get for 2A? Okay. Emma M, what'd you get? Good. It should be 34. So this one, I'll show you guys the initial setup here. The perimeter is 93. So to find perimeter of a triangle, you just add up all the sides. So you should just add up 31 plus x minus 6. Combine like terms, solve for x. You get x is 34, which then you should take and plug back in. Okay. What kind of triangle is that based on the sides, Mary? Good. Scalene. Everyone okay with that? Okay, Sean, what'd you get for letter B? Good. X equals 19 yards. Sean, what kind of triangle is it? No, you can't. You don't know. We don't have any information about the angles.
Oh, sorry.
Good. Isosceles. So really on this one, 2 of the angles are going to be the same. It looks like it's acute. Doug, head up, please. But don't assume that, because sometimes they're not drawn to scale, and that's one thing about geometry that drives me crazy. Is they might not be drawn to scale. Okay, Emma? Okay. Yep. What I do is my initial setup is 64 equals, this is x and this is x. X plus x is 2x plus 26. Everyone okay? Give me a head nod. Is this easy? Okay. All right, letter C. Mary, what'd you get? Awesome. The sides are all 17, and it is equilateral. If it's equilateral, what else is it? If it's equilateral, what else is it? Briar, what else is it? Yes, but that's not what I'm looking for. Annalise? Yep. If it's equilateral, it's also equiangular, which means all the angles are 60 degrees, which Briar's right. It is also acute because they are all less than 90. Equilateral and equiangular go together. Okay, so it's always going to be both of those. Any other questions on that? Okay. Okay, so the closing. Let's see how you guys did on this. You could have used your conversion chart if you needed to. Matt, 3 gallons equals how many quarts? Good job. Yes, you may. Justin, 8,000 pounds is how many tons? Awesome. Doug, 1 week is how many minutes? Nope. Nope. 1 week is how many minutes? Briar?
10,000.
Good. 10,080 minutes. Okay, you got to read carefully, okay? Charles, 1,000 millimeters is how many meters? Good job. All right. Any questions on page 1 or 2 of the notes? Annalise? Okay. Okay. So, Charles, do you want to explain how you got D, or did you use the calculator? Okay, so you just kind of used prior knowledge. Okay, Sean? Uh-huh. Okay. Uh-huh. Yep, and you use, it goes in that order. Uh-huh. Yep. Yep. Good. Annalise, that's just like the chart I gave you guys that, you know what I'm talking about? Okay. But you could also have used where the meters was in the middle and it had all these arrows going. That also helps you, it tells you that 1 meter, there's 1,000 millimeters. Okay. Briar. Perfect. Perfect. Emma. B. 1 ton is 2,000 pounds. So if you know that 1 ton is 2,000 pounds, that makes it a little bit easier. Okay. It's on your conversion sheet. I'm not expecting you to memorize all these. I just like to throw them in there every once in a while. What do you mean there were 2 different labels? We don't need to use kilograms. You need to use this one. 1 ton, there's 2,000 pounds. That's why. All right, so I need you guys to turn. Oh, okay, everyone close your eyes for a second. Okay, open your eyes. I thought I erased something. Okay, turn to the inside of your note packet. So like the gold sheet, turn to the back of the gold sheet. We're going to talk about something here, but it's not in your notes. So turn here. Okay, so we're going to, before we start an introduction to polygons, I want to classify them. So make like a big box if you want, like, or a table if you want. If not, you can just list them. Put sides on one side and name on another. It tells you right here, Jeremy. Okay. 3, 4, 5, 6, 7, 8, 9, 10, 12. And I want you to write down all the ones you think you know. So most of these you know. I'm thinking when you get to the end, you might not know them. Yeah, I can show it to you. There is a polygon song. That's right, I always forget about that. Who else had cookies? Do you want another one? Or you could save it for later if you don't want to know. Emma, do you want another one? Okay. Anyone else who had cookies want another one? You could save it if you don't want it now. You're welcome. Sorry, Doug, you choose either cookies or points. You can't choose both, okay? You guys had the choice. That's okay. Just sorry. That's fine. Yep. That's okay. We're not doing 11. We're doing 9, 10, and 12. Shut this off so we can see better. Okay. Charles, what's 3? Real hard, right? Annalise, what's 4? Nope, they're all polygons. We're classifying polygons. These are all types of polygons. Nope, because a rectangle has 4 sides. A rhombus has 4 sides. A diamond has 4 sides. A kite has 4 sides. Sean? I call it a diamond. Good. Quadrilateral. Okay, 5 sides, Briar. Good. Pentagon. 6 sides, Donatus. Good. Hexagon. 7 sides, Alyssa. Yeah, you call it that. There's another name. Charles? Yeah, you can call it either one. We'll keep heptagon up there, but I always hear both. In elementary school, did you guys learn heptagon? Okay. Or you didn't. Okay, and septagon's fine. Yeah. Okay, but either one's fine. Every year I always hear 2 from the 6th graders. Okay, Justin, 8. Good. Octagon. Number 9, Donatus. Good. Nonagon. 10, Emma. Good. Decagon. What's 12? Charles. Dodecagon. Anything beyond 12 is what? Matt. No. I like that, though. No. That would be kind of cool, though. Justin? Yes. Anything else is N gone. So, like, 13 gone. 14 gone. It's pretty boring, actually. 15 gone. Shh, shh. 6th grade. Okay. Charles. So anything else in the geometry book, in the pre-algebra book, we use N gone for anything else. Okay? Annalise. There's not an 11. Based on the pre-algebra book and the geometry book, we just use 11 gone. Well, yeah, we're just using 11 gone. If you Google this, you get many different things for 11. Like this one that I have, they have undecagon or hendecagon. So, but the pre-algebra and the geometry book uses 11 as 11 gone, which is what I'd prefer you to use, because your geometry teacher will show you the same chart. Annalise? Yeah. Yep. You know most of them. Matt? There's no such thing. I'm getting to that. No, a circle is not a polygon. All right, so let me start 10-2 so you have an idea of what a polygon is, okay? And we're probably going to end with this. Let me just kind of give you an introduction of what a polygon is, okay? That way you understand, like, a circle is not a polygon. And I guess before I explain it, does anyone know why a circle is not a polygon? Oh, a lot of you know. Sean, why not? Good. Correct. Correct. Yep. Matt was trying to tell me you could, though. Justin? I'm just kidding. No. Correct. All right, so definition of a polygon, okay? A closed plane figure whose sides are segments that intersect only at their endpoints. Polygon, a closed plane figure whose sides are segments that intersect only at their endpoints. So it has to be closed, it has to have segments, and it has to intersect. Donatus, open up your notes. Only at their endpoints. So I want you to underline closed plane figure, segment, and intersect only. If you have your hand up, just give me a minute to keep explaining. I should be able to answer your question. So hold on. Hold on a sec, okay? So here's some examples if you need to draw something. This is a polygon because it's closed. It has points at the intersection point. So I can draw all these points on here. Triangle is closed. All the sides are flat. There's not any curved edges, and it's closed. Same thing here. It looks like a parallelogram. It's all closed. All the sides are segments. They only intersect at their endpoint. Do you need a Kleenex? So let me show you some that are not polygons. Okay, so not a polygon. This one in green over here, it crosses. So no, because it doesn't just cross where the segments meet. Okay, it intersects in the middle. Not a polygon because the edges are not segments, they're curved. Okay, you cannot have curved edges on a polygon. This one is open, not a polygon because it's not closed. So these ones are not polygons. These ones are polygons. You don't have to draw them unless you want to. This is just me talking through them. Now, a regular polygon, this is something a little bit different. If it's a regular polygon, that means all the sides are the same and all the angles are the same. You will hear this word a lot in geometry, especially when you do proofs. If it's a regular polygon, all sides and angles are exactly the same. Okay, questions? Okay, we're not getting off track here. So if you have a question, hand up. Jeremy.
How does the last one make polygons? How is that not a regular polygon?
This? You cannot go by what your eyes think. This could be 12 inches, this could be 11 inches. Okay? Correct. You cannot, things are not always drawn to scale, so do not go by what your eyes are telling you, okay? Go by your brain, not your eyes. Yeah. Cannot assume, you need to make sure you have actual numbers there. Mary, question? This thing? Oh, I was counting that. Did I count this one yet?
Yeah.
Okay, yes, yes. Well, you again, like it looks like it is, but we can't assume that because we don't have measurements. It could be. We could measure it, but that's not the point of this right now.
But if they all work.
If they are all this, yes, you're exactly right. If these are all the same and the angles are all the same, then yes. Yeah, it's so hard to tell sometimes, and I do agree with you. That really looks close. Sometimes the book messes things up too. Annalise, question? Yep. Yeah, you can't do it. Okay, Donatus, is this a question? Okay, then hold. Okay, go ahead. Wait, which one, Donatus? Are you looking at this one? These up here?
No, this part right here.
Well, we're not worrying about this right now, like this angle all in here.
Yeah.
You're not finding that angle.
But what if
This is not 90 degrees, but this one's 90 degrees.
then all the angles aren't the same?
Well, but technically we're not finding this one. We are not classifying whether this is regular or not. We just wanted to know whether it was a polygon or not. We're going to get to what you're asking though. Okay, but that's not what this is for. We need measurements or we need protractors for that. Okay, so we're not there yet. Justin? Yeah. No, that's not one. Nope. Emma.
Shapes that like things have lines,
Yeah.
but they don't like make an actual shape.
Draw for me what you're saying.
Like number.
Yeah, that's a polygon. Yep. Yep. All right, so I'm going to stop there because we need to make sure we have a better discussion with all this tomorrow. I just wanted to get you thinking about what a polygon is. Okay, your assignment, don't get a book yet, but your assignment's going to be in the book, page 513 and 514. And you're going to do numbers 1 to 20. Nah, shouldn't be too bad. I just want to make sure there's not anything with Pythagorean's theorem in here. No, there's not. Okay. So before you go, if you want to get your book, that's fine. Make sure you have written down pages 513 and 514, numbers 1 to 20. Annalise? Not now. They're not done. Remember at the beginning of class I said they're not done, so I can't show you your grade. No. I told you at the beginning of class. They're not done. Okay, you guys can get packed up. If you need your book, get your book. Tomorrow we will finish up 10-2, and I will pass tests back tomorrow